It may not look like it, but this is the first periodic table. It was conceived by a little-known Frenchman called Alexander-Emile de Chancourtois in 1862. This was 7 years before Dmitri Mendeleev's first periodic table, which is the ancestor of the one we all know today. The clever thing about de Chancourtois' system is that vertically down the cylinder, the chemical elements fall into groupings. So here we have lithium, sodium and potassium, which we know today is all part of group 1, or the alkali metals. And de Chancourtois would have known that these share similar chemical properties, such as they're all soft metals. They can be cut easily with a knife. They also react massively with water. This is a feature common to all periodic tables, but de Chancourtois was the first to do it. So why isn't de Chancourtois better known, and why didn't he get the credit for coming up with the first periodic table? Well, it's mostly due to a publication problem. The publisher didn't actually include a diagram of his three-dimensional spiral periodic system, which, as you can imagine, would be very difficult to describe in words. And it made the paper rather obscure and difficult to understand as a result. So it's not surprising that it took 30 years for his contribution to be rediscovered. De Chancourtois was one of 6 people to come up with a periodic table in the 1860s. And the key event which paved the way for these ideas was in 1860, when all the world's leading chemists came together to come up with standard values for all of the chemical elements. This model of a system was actually made by the Science Museum in 1925, ahead of their earliest display on the periodic table. And it's probably the very first physical realisation of de Chancourtois' system. The Science Museum changed a few details from the original system. For example, here, they've anglicised one of the elements. We know it today as N for nitrogen, but in de Chancourtois' original system, he had it as AZ for azote, which was the term introduced by his countryman, the famous Antoine Lavoisier. Another difference is it only includes the top third of Chancourtois' system. It stops down here at zinc, so the original would have been 3 times the height. The original system would have had tellurium at its halfway point, and it's for this element that de Chancourtois named the whole system the telluric screw. This object and its history makes you wonder that if de Chancourtois' contribution had been recognised at the time, perhaps he would have been a household name like Mendeleev.